Hello YouTube, how are you? This is What the Math, and today I'm going to try to recreate a replica of Orion Mission, which is only a few days away. This is the mission by NASA trying to launch a rocket that is powerful enough to eventually take us to Mars. Now this rocket is actually right here on top. Right now it's covered by fairings, and I'm going to remove these because I actually wanted to do this as basically a stock only, no mods, nothing. So I'm going to remove these when I launch the rocket, but this is what the actual model would look like in real life, or something similar to this. And this part, the top part, is actually carried by this really powerful Delta IV heavy rocket. So these are real life replicas of Delta IV, and they have orange tanks and everything. They have these huge caps on top and three really powerful engines on the bottom. Now this is only the first stage. The second stage is when these two separate and you have the middle part carrying itself to the orbit, and then once this separates you have the other part. I'm going to show it to you in a second. And so let me just remove the Delta IV, and this is what the actual Orion would look like in real life and in Kerbal life, basically. It sort of has this shape. I tried to recreate the shape very accurately, but it was very difficult because I don't have exactly the same parts as the actual model. So you have the capsule right here where I think it's something like 4 to 6 astronauts will be located. Then there's something in the middle here, but I could actually not figure out what it is because NASA did not provide information. So I strapped on an SAS module just to make it look like a real model. Then I did put some RCS controls just because I wanted to have that for more control in space. And you have the fuel tank right here with an engine on the bottom. So it sort of looks like this, and this is actually this. Oh, and right on top you have the emergency module, which is it's used for when things go wrong, but it's also used in this particular launch to try to take this part away from that part. Just basically separated from the bottom part. I'll show you how it works when I launch my rocket. But the actual Orion model, or sorry, Orion rocket, is just this part. This is Orion right here, whereas this on the bottom is Delta propellant, or so not Delta propellant, but basically Delta rocket. This is a heavy Delta rocket. There's different models of Delta that NASA used before, and they're using the really heavy module this time to launch the Orion. Alright, so enough talk. I'm gonna put my rocket on the launch pad, accelerate time just so I can actually get to the daylight because it's a little bit easier to see things that way. And here you go. I did remove the fairings because it just wasn't stocky enough. I want to use just the stock parts. And you have our 3 Kerbal astronauts: Danby Kerman, Harman Kerman, and Tanbas Kerman. People I have never heard of before, but they are here to launch their beautiful rocket. They're not looking at each other because they're too nervous. This is going to be a beautiful launch. So let's just start our countdown with, let's just start from 3. 3, 2, 1. Alright, and launch. I should probably do this view instead because it's a little bit easier to see things. And so right now I'm just going to be launching like basically regularly, going to 10,000 meters first and turning 45 degrees and slowly getting into a parabolic arc afterwards. So I'm just gonna skip this ahead and show you the rest. Alright, and so here we go. I've just officially reached an orbit around Kerbal, and this was actually the first stage of the Orion test as well. So first they'll actually try to reach the orbit, and then what will happen is the top part, the Orion part, will separate from the Delta rocket, and this is what I'm gonna simulate here by basically pressing my spacebar. And you can see that my the safety module on top has just blasted me away from my Delta rocket. Basically it saved me. The thing is, I forgot to attach a separator here, or separatron thingy, and so it's actually going to stick with me for now. In the real rocket, in the Orion rocket, this will actually fly away and it will be gone. And there's also going to be fairings that will be actually released as well, just to lose some of the weight. Alright, so this is the Orion rocket. Now it's in the last stage of its flight. Now, we did reach an orbit around our planet, our home planet. Now, what they are trying to do with Orion, though, is they're trying to actually have this rocket reach a very eccentric orbit around our planet. So we're here right now. We took off from right here, and so just like in the real mission, we're actually going to fly almost completely around our planet, and then around this point, we're going to blast our engines until we reach a very, very, very eccentric orbital path around our home planet. Hopefully without any interference from the moon. Alright, so this is good enough, and this is actually quite realistic of what it will actually look like. I think even more eccentric. Yeah, something like this. Maybe a little bit less. And then right after this, what Orion Rocket will do is right on top here, it's going to decelerate a little bit and then decrease its periapsis so that it actually intercepts the Earth atmosphere, or in our case, Kerbal atmosphere, and then land back on Earth. So our goal right now is to essentially reach this eccentric orbit, and the reason we're doing this is because this is very close to escape velocity from our planet, so that we can actually, we're testing if this module can actually try to reach Mars, and then essentially take this capsule with people in it and with other stuff to Mars. Now, in order for us to test this, we're going to align with our waypoint target, the blue point right here. And so this rocket will actually be blasting toward this point in around 14 minutes. And this will give us that very eccentric, super eccentric orbit. And to get this orbit, I actually need in this game I need to increase my velocity by almost 900 meters per second. But in real life, it's actually much higher. I think it's probably a couple of kilometers a second, if not more. I think it's even more than that. Now, this particular design, this rocket design in the game is actually very efficient. I currently have, where's my delta V? Right here. I currently have almost 3,000 delta V left, so it's actually quite enough for me to even go to the moon in this, if I wanted to. But we're not going to do that. We're actually just going to try to follow the Orion mission and do the same thing they're doing. I think the only difference between my rocket and their rocket is that they do have fairings, and unfortunately Kerbal Space Program does not have fairings yet in the stock parts. And the other thing is that I totally forgot to separate my launch escape system, LAS or LES. This was supposed to fly out and not come back to me because it's actually giving me extra weight. This is why my delta V is a little bit higher than it should be. If this wasn't here, I would be able to reach or have a lot more delta V. Anyway, so let's go into our last stage of the mission. I'm going to accelerate time. We're going to fly through and orbit around Kerbin, just like they will be doing this with Orion Rocket. And in around a few seconds now, I'm going to blast my rocket. And now, alright, so this is the blasting part. So engage rocket and blast. And so what this is doing right now is that it's increasing my eccentricity, or eccentricity of my orbit, until it reaches this super eccentric orbit. And then using this, I'll be able to test the efficiency of the Orion. Alright, and there you go. So this is our super eccentric orbit, and this is what Orion Mission will try to achieve as well. I'm gonna accelerate time, and let's just fly away from Kerbin. But we're not actually leaving its orbit. We're still in the orbit around the planet, and just like the Orion mission, we will try to return to the planet now. So this part is actually not very difficult in this game, but it will be pretty challenging in real life, because here a small mistake will actually send this rocket flying away into the abyss, and it will probably never return. Now at this point right here, we're going to decelerate and then try to get our periapsis very specifically into the Kerbal atmosphere. So this is what the Orion is trying to achieve as well, except they're using Earth atmosphere. Now for the Orion mission, this is actually one of the more dangerous parts, because a small miscalculation here will make their capsule re-enter Earth atmosphere at an angle that is way too steep, which means that it will most likely just destroy itself. It will be destroyed by the atmospheric pressure. In this game, it's not as much of a problem because it's very forgiving with re-entries. Oh, look at this beauty. So beautiful. So it's a lot more forgiving with its re-entries, and usually you don't get destroyed by you know, going too fast and too steep into the atmosphere. But in real life, though, it's a big problem. Alright, so in about 1 day, actually, I don't think it's actually going to be taking this long in real life. It's a lot. I think I actually flew too far away from Kerbin, but in real life it's actually, I think it's about 10 hours that it will take them to get to this part. And so let's just accelerate a little bit more, and around our waypoint I'm going to try to decrease my velocity by 7 meters per second, which is actually very precise. It's very specific, so one miscalculation on my part will mean that I might be losing all my Kerbins. All my Kerbals might be dying because of the re-entry that is not actually optimal. So currently my orbital speed is 136 meters per second, and that's because I'm so far away from Kerbin. And technically I could definitely reach on a circular orbit around this point, but we don't want that. We actually want to return back. So right here, let's blast our rocket a little bit, and maybe a little bit more. Okay, that's good. Now I'm gonna still keep this part because I want to have some control closer to Kerbin when I get back there. And so now we're going to basically re-enter Kerbal atmosphere. And if Orion mission is successful, at least up to this point, we'll know that at least the rocket works. Even if the re-entry fails, at least we'll know that the rocket works fine and we can use it to reach Mars. The thing is, they're not actually using any real astronauts this time. They only have a bunch of different equipment that will measure various things. And so it's not dangerous for us to lose the capsule, but it would still be nice to see if we can return it back to our home planet. So here we go, approaching Kerbin at a really fast speed. I'm just going to need to double check if I'm entering this correctly. 40 kilometers, maybe a little bit less than that. I'm going to decrease my speed just a little bit more and give myself a slightly better re-entry. I think I want this to be 35. There we go, perfect. 35. So at this point I can actually release my last stage and prepare for my descent. Now technically I'm not supposed to have this, but I can't really help it right now because I forgot to attach a separatron between these two parts. That was my mistake. Anyway, so here we go, entering the or not entering, but approaching Kerbin, and in a few minutes we're going to enter its atmosphere. And I think we'll be landing on the dark side, unfortunately. I didn't actually plan to calculate where I'm going to be landing, but it's okay. This is good too. So we are approaching this really fast. So this is what they're actually going to be worried about in the real life as well, because here the speeds will be really high, much higher than usual with normal re-entries. And so what you'll have to do is they will have to use the capsule controls to try to orient it so that it's actually falling, or basically approaching atmosphere exactly not this way at all, exactly where is this direction I'm looking for? Here you go, exactly this way. So this part right here, this has the highest amount of heat shielding, and it's actually a new heat shield that has been recently invented just for this mission, and it's supposed to be able to survive temperatures up to like 4,000 Fahrenheit, which is really high. And when it starts heating up, and you'll see this in a second as we approach Kerbin, when it starts heating up, you'll have this fire around the capsule, and it's actually it's a type of it's not a material, but it's actually a type of a substance. It's called plasma, and plasma is, one thing about plasma is that it prevents anything electronic, specifically electromagnetic waves, to go through it. So we're going to lose total control of the capsule if we're trying to control it remotely. So it has to try to land itself, either using the pilots or some kind of artificial intelligence, or basically onboard computer. And this is what they're going to be using. They're going to be using autopilot to try to maintain the specific entry parameters and try to land very precisely. Not land, but enter atmosphere very precisely. Because right now my speed is 3 kilometers per second. In real life, in the real mission, this will probably be something like 11 kilometers per second, if not 12. and it will be really high speed. And so this capsule is going to have to survive a lot of heat, and a lot of air pressure that is going to come toward it in a few seconds as soon as I enter the Kerbal atmosphere. There we go. So right now, at speeds of 3200 meters per second, I'm going to start experiencing slightly warmer than usual temperatures. And even though my Kerbals seem to be pretty chillaxed about it, I'm a little bit worried. Now luckily in this game it's not really, unless you install a mod that starts making things a little bit more realistic, it's not usually a problem when you re-enter atmosphere. It doesn't really kill you. But it's kind of scary nonetheless, because you'll see all this fire in a few seconds. As soon as I reach, I think it's around 30,000 meters. But right now my speed is still pretty high. I'm still going at over 3 kilometers per second. You can kind of see how Earth beneath me is going really fast. And I'm entering Kerbal atmosphere at a really high speed. Now, this part here, this is actually the most difficult part of the mission, even though it doesn't seem like it, but a small miscalculation will, or essentially this is what's going to happen. If you try to approach this at a too high of a height, oh, there we go, there comes the fire. If you approach this at a too high of, or basically altitude that is too high, what will happen is your capsule will just bounce off the atmosphere and will return back to orbit. And that's not what we want. If you approach this at a too steep of approach, so basically if you're going down this way, you will be approaching it way too steep, and what will happen is your capsule will most likely, be destroyed. It's not gonna be able to survive such a huge amount of temperature and pressure, and it's just going to destroy itself. And oh no, I think I might be a little bit in trouble because I might be going a little bit too fast still. My speed is not decreasing too fast. And so this is actually the problem that I was just talking about. I am bouncing off the atmosphere right now. I'm going to be returning back to orbit, which is not what I wanted at all. I don't think I'll be able to return to Kerbin right now. My speed has not decreased by enough, so I'm not going to be able to re-enter on the first try at least. I'm going to have to orbit again and then re-enter on the second try. Now, even if this happens during the Orion mission, it's not actually a problem because there's no living things on board, so they don't have to worry about food or water or anything. So nobody's gonna die. We can still recover the capsule. But the only problem is that if this happens, we don't really know where it's going to land. It's going to land in a completely different spot that we actually have not pre-planned for. And the other thing is that there we go. So we're going to be orbiting around Kerbin just one more time and returning to actually possibly a very similar spot on the next orbital passage. Now, one thing I forgot to mention, and one thing that is actually really important for this mission when it becomes manned, so when there's actual real people on board, is that when we reach a certain height, it's actually several hundred kilometers, there's a part around our planet that is called Van Allen's Belt. And what this belt is essentially, it's a concentrated sort of part of our atmosphere or upper atmosphere where there's a lot of radiation, a lot of really dangerous radiation. Now, for most astronauts, it's actually the biggest concern because you can, if you pass this belt, you will be essentially radiated by huge amounts of really dangerous particles that may cause serious health problems. A lot of astronauts, especially astronauts on the International Space Station, do not get to experience this because we don't go high enough. But those astronauts that went to the moon, especially during the Apollo mission, they did get to experience this twice, on the way up and then on the way down. So if we do send people through this part, our capsule has to be really highly protected. And this is what they're testing right now as well. Their capsule will have some serious shielding, like lead shields and all kinds of stuff that will hopefully protect people from radiation when they pass this belt. Okay, looks like I am decreasing my speed after all, so I'm gonna realign myself with my velocity marker again, and in a few seconds I'm going to start burning into the Kerbal atmosphere at speeds that are slightly lower than before, but this is a lot safer as well. And I may actually, well, I know I will be landing on the bright side, but I may also be landing in the water, which is actually what the Orion mission wants as well. Because if they land in the water, especially in international waters, not only is it safe for both the capsule and the people on the ground, but also it's a lot easier to recover your capsule using, you know, just ships. You can just then send a ship to recover the capsule. Alright, so here goes the burn. So we're gonna start burning into the atmosphere, and this plasma around our spaceship will make any kind of communication impossible. So right now I cannot communicate to my Kermans. Danmy Kerman, Herman Kerman, and Tenbus Kerman are all on their own. That's why their faces are so grim right now, because they know if things go wrong now, that's it. They're finished. I was actually going to try to put a drop parachute here, but I just didn't have enough space. But in the real mission, they will actually release a drop parachute right now, which will slow down their descent a little bit more, because they'll be going at speeds that are pretty high. At some point it will be, even in the lower atmosphere, it's going to be something like 300 miles per hour, and they'll need to use drop parachutes to slow down. I'm actually going to just simulate this with normal parachutes when we get to the lower atmosphere. And right now I'm going at speeds at around 300 meters per second. We've survived the dangerous part with the re-entry and the heat shield, so our heat shield survived. And right now we're just following toward, I believe it's an ocean. Yes, it's water. We're following toward the water, and at this point this is where the drop parachutes will come out and will slow down our descent a little bit. And the final stage will have these 3 large parachutes that will then descend us down to the water. And unfortunately my capsule is a little bit tilted because I have this huge thing on top. That was also my mistake. I did not separate. But in the real mission, you'll just have this part, this capsule right here. The top part is going to stay in space. It was supposed to stay in space here too. I just forgot about it. Alright, so here we go. Oh no, that is so not what I wanted at all. That is not what I wanted. No. Alright, our Orion mission officially went a little bit upside down, and we're going to be entering water nose first, which is, I guess it's fine. It's not a big problem. I may actually lose this part. Our capsule will be fine though. It's not going to be destroyed, or at least I hope it's not going to be destroyed. And if we take a look at what these guys see, they see the water approaching really fast. How are you feeling? You feeling good? Good. I'm glad you're feeling good. Everyone is happy about it. Here comes the water. Let's look at it from this angle. Alright, and we survived. So now what we'll be doing is, in real life at least, this will have a bunch of flotation devices around it, and it's just going to wait in the water until a Navy ship rescues it. And this is it. This is essentially it. You guys can come out and play a little bit if you want. Let's let go, and let's go swimming. Yay! Alright. Let's go for a little swim. And that's it. That's the end of the mission. This is Orion in a nutshell. And this is Mr. I actually don't know who you are. This is one of the Kerbans, and he's saying goodbye to you and thank you for watching. Subscribe for more Kerbal Space Program missions, and check out some of the other videos I posted. Bye bye guys.